Welcome to the Crazy Hat Chemist. So another video here on acids, bases, and titrations. So before I get started, I want to mention a couple of things here. I got some really cool stickers here. So for your hydro flask or your computer or something like that, just donate to my website. You get one of these. Or check this out, even some more merchandise. A t-shirt. Isn't that cool? Check it out. It's on the back too. You can even donate to my website and get some of that merchandise. And I've got a new hat here today from Miss Denny, a teacher at my school. So wait for that at the very end of this video. Don't forget to give me a thumbs up on the video if you like it, subscribe to my YouTube channel, and pass it on to all your friends. Okay, so let's get started here. Bam! So today we are talking about the Henderson-Hasselbalch equation. Okay, so we're going to consider a weak acid. That's going to be HA for the generic weak acid and its dissociation. That's right here. We got HA aqueous, we got the equilibrium arrows, we got the hydrogen ion plus the conjugate of the acid. That's HA minus 1. Okay, we've gotten rid of the water and the hydronium ion, but that's okay. Okay, so we're going to consider the dissociation of this right there, and we are now going to write the Ka for that above expression. Now remember, the Ka is the products of the reactants with the stoichiometric coefficients as exponents. So there we go. That's the Ka is equal to the hydrogen ion and its conjugate of the acid on the numerator term, and on the product on the denominator term is the HA. That's that weak acid. Okay, it's a Ka because it's an acid. That's the equilibrium constant expression, or the acid dissociation constant, really, truly. We're going to solve for the reciprocal of the hydrogen ion concentration. So what I want you to do is pause the video right here, and I want you to solve for the reciprocal of the hydrogen ion concentration yourself, and then you're going to restart the video. Okay, you've paused it. Now you are going to restart it, and this is what you get. So 1 over the hydrogen ion concentration is equal to 1 over the Ka times the A minus 1, that is the conjugate of the weak acid, divided by the weak acid itself, that's the HA. All right, so take a look at that equation. This is going to be very important here. Okay, so by definition, the pH is equal to the log of 1 over the hydrogen ion concentration. pH is negative log of the hydrogen ion concentration. Don't forget your rules of logs. Okay, and furthermore, we got the pKa is equal to log over 1 over the Ka. Again, pKa is equal to negative log of the Ka. Remember your rules of logs and negatives and reciprocals. Okay, therefore, by taking the log of the equation below, and here's our equation below of which we had on the previous slide, and that's the 1 over the reciprocal of the hydrogen ion concentration. That's what you derived just a little bit ago. We're going to take the log of both sides. So what do you get? pH is equal to pKa plus log of the conjugate of the acid divided by the weak acid itself. Okay, and this simplifies to the following. pH is equal to the pKa plus log of A minus 1 and over the HA, the weak acid. So the conjugate base over the conjugate acid. This is called the Henderson-Hasselbalch equation. We just derived it right now, and it's a wonderful equation. So let me tell you a little bit more about this. Okay, there's that Henderson-Hasselbalch equation that we just derived. Okay, the pKa is equal to the negative log of the acid dissociation constant. Okay, the numerator term here of this fraction is the conjugate base. The denominator term is the conjugate acid. Okay, the Henderson-Hasselbalch equation works well for very dilute solutions. Okay, if the conjugate base and the conjugate acid are the same, then the ratio is 1, and the log of 1 is 0, resulting in the pH is equaling to the pKa. In this case, the acid will be half dissociated. This is a very important concept here for titrations, which we're going to be talking about in just a little bit. Okay, this shows that the pH is determined largely by the pKa of the acid, and then is adjusted by the ratio of the conjugate acid to conjugate base. Okay, And that is a fantastic video here. And check out my new hat from a wonderful colleague of mine. It's World Peas. It's very similar to World Peace. If you like that video, give me a thumbs up, subscribe to my YouTube channel, and of course, don't forget about the merchandise, the sticker right here, and of course, get yourself a cool Crazy Hat Chemist hat. Get yourself a cool Crazy Hat Chemist t-shirt. Yeah, baby! All right, I'll see you next time. Bye for now.